Hello, everyone. First of all, I would like to thank you all for joining this session. We'll be talking about securing web views and the story behind CVE 2021 21136. I'll be walking you through this presentation with my friend and co-speaker Imdad Mohammed. Let me start this with quickly introducing ourselves. My name is Shiv Sahani. I work as Senior Associate with JP Morgan Chase. I'm one of the contributors in OWASP MSTG and also the author of The Clear Matter of Securing Android Applications. Over to you, Imdad.
Thank you, Shiv. Hi guys, my name is Imdadullah Mohammed and I'm currently working for Grab as a security engineer. So at Grab, I'm leading different engineering teams in the application security initiative. Over to you, Shiv.
So before we go ahead, a quick disclaimer. Any opinions that we are going to express over here would solely belongs to us and are nowhere related to our current or previous employers. So basically, this would be the agenda for today's session. We'll be starting with introducing CVEs. Later, we'll talk about web views, wherein we'll discuss how exactly web views work. Once we have established the foundations, we'll be talking about journey on CVE 2021-201136. And later, we'll discuss about the in-depth analysis that we performed and submitted to Google in order to claim the CVE. Last but not the least, we'll talk about common web view-related security issues that we have observed over time, and the ways wherein we could prevent those issues and make our mobile apps secure and robust. So let's start with CVEs. So basically, CVE is nothing but an acronym used for common vulnerability exposure. It's actually a unique identifier that is associated with a vulnerability in a publicly available software package. CVE 2021-21136 is actually a CVE unique identifier that is associated with a vulnerability in Android Webviews implementation. Over the time, what we observed was a lot of mobile applications were actually leaking users' auth tokens to third parties. And when we dig deeper into it, we found out that this was happening because of a flaw in Chromium implementation for Android Webviews. We'll talk about the in-depth analysis in the upcoming slides. Now let's understand what a WebView is. So basically, WebView is one of the mobile app components that allows mobile developers to load web content directly into their mobile apps. So you could consider web views to be dedicated web browsers for our mobile apps. And they support the concept of code reuse, wherein the life of mobile developer it becomes far more easier because they can just load the already existing web content into their mobile apps. So if you see an image over here, we just provide the URL and the web content corresponding to that URL is loaded in our own app through web views. So as I mentioned, they support the concept of code reuse, and that is why they're extensively used in the current era of mobile application development. Now we know what a web view is. Let's see how it works. So as I mentioned, we just need to provide the URL, and it loads the content corresponding to that URL. So basically, we could leverage load URL API, and we just pass the URL to that API, and the corresponding web content is loaded in our mobile app. So this was a simple one wherein we have a normal load, just provide the URL and the corresponding content is loaded. Let's see what happens when we want to load the content which is protected through authentication. For example, we want to load user's profile page. In those scenarios where the content is protected through authentication, we would need to provide auth data. Otherwise, backend won't release the resources or the web content. We can do so by leveraging the same load URL API, but this one is the overloaded version of the previous one. When apart from providing the URL to be loaded, we also provide a map. So basically, this map is having key value pairs where key is the HTTP header name and the value is the corresponding value. So what happens is, what all headers we provide as a part of this map are being sent or attached to a network call that we'll make while loading the URL. And now what we have done is we have attached the authorization header to it. So now it becomes an authenticated request, and backend would accept this request because we are passing the auth token and would release the protected content. Once that content reaches the front end, it would be rendered. So as I mentioned, now there are two kinds of loads. One is a normal load where we could load publicly available data, publicly available web content. And the second one is the authenticated load. It would be leveraged whenever we need to access or load a content which is protected through authentication. And now we know what exactly WebView is and how they work. Let's understand deep links with help of an example. So have you ever wondered while you're browsing content in your mobile app browser and you click on a link and it opens a specific content in the mobile app that is installed on your device. For example, if you see over here, while Googling, I saw a product, I click on a product and it opens that particular product in the e-commerce app that is installed in my device. So the things like this happens because of deep links. So deep link is nothing but a URI, which helps improve users' experience by opening a specific content in the mobile app. Another example could be this Facebook deep link, wherein we have Facebook's /test profile and the profile ID. Once this deep link is triggered, it would actually open user's profile in the mobile app that is installed. So now we have established the fundamentals that would be required to understand the technical details around the Chromium CVE. My co-speaker Imdad will be taking over from here. Over to Imdad.
Thank you, Shiv, for such a detailed information about the basics of web views and deep links and what a CVE is. So let's try to understand a bit more about our journey towards CVE 201201136. So in this specific slide, what we are talking about is a basic OAuth use case, wherein we are trying to understand in a OAuth workflow what happens in case of a mobile application. So here we have, as you can see in the specific diagram, we have three components. The first one is our mobile application. We have an identity service and we have a third-party service. So let's assume that our mobile application actually integrates with a lot of third-party services. And if you have this mobile application and you click on third-party tile inside the mobile application, the first HTTP call will go to the identity service. In this call, it will send the client ID as well as the redirect URL. The redirect URL will be of the third party. In this specific request, in the authorization token, the mobile application will also send the authorization token because this is an authenticated load. Now, the identity service will first the identity service will validate the authorization token of the user, as well as it will validate the client ID and the redirect URL. After it validates, then it will generate an ID token for the specific third party and then send it in the location header as a response to our mobile application. Now, as soon as the mobile application receives a 302 response along with the ID token, it will redirect to the third party in the last call which we are seeing here. So here the mobile application is being redirected to the third party URL along with the ID token. So this is a normal workflow which we often observe in a mobile application where we are trying to access a third party service. Now in this slide, let's understand the bug at a very high level. So as we said earlier, while reviewing this flow in the mobile application, what we observed is in the call where there is a redirect to the third party URL along with the ID token, the web view, the Android web view, which is in the mobile application, was also forwarding the user's authorization token to the third party. So basically, it's exposing the token which is required for the user to maintain session. So this user's token was actually being sent to the third party service, as you can see over here. So now that we have understood how an OAuth workflow works and in which flow we have identified this bug, let us see what was our initial observation. So initially what we observed is that while you're trying to implement a web view in Android, you would of course use load URL and the URL that you're trying to load in your web view. So in this specific example, the code snippet that you're actually seeing is that we're trying to load an authorization header using the additional HTTP headers. So this method will actually do an authenticated load, as we have seen in the previous slide what an authenticated load is. So here we are trying to do an authenticated load and sending the authorization header to this specific URL. What we observed is that so the authorization header, which is being sent to the URL, was also being sent to any other host which was triggered in the specific process. What does this mean is that irrespective of the origin, whenever there is a 302 redirect, the authorization header, which only belongs to the client, was also being forwarded to third party. So now that we have seen the bug at a very high level, let's try to understand the timeline. What are the problems that I faced, and what all we did from the initial observation until we got a CVE. So back in August 2019, that is when we have observed this during a security research, that the header is being exposed to third party. Then in December 2019, we wanted to, we suspected that this could be vulnerability in the Android Chromium. So we decided to have our own implementation and try to replicate an exact scenario which we observed in a production environment. So what we did is we developed our own POC application as well as a backend application, and we tried to document all our observation, and we finally submitted it to Google. So in January 2020, we got a response from Google that they were unsure. They said that this is actually a feature because of compatibility issue with the older version of the WebView, and at that point they were unclear whether they would be able to fix it, because they didn't know that whether it would break the application or not. So after that, there was a couple of back and forth conversation with Google, emphasizing on the impact as well as making them explain different use cases where there could be a leakage of users token on to the third party. And finally, in February 2020, Google accepted our submitted vulnerability as a security issues, and they said they will need more time to fix it. So they came up with a specific plan for the fix that we'll talk about in the next slide. And finally, in November 2020, the official fix was released in Chromium version 88. So we just saw the bug at a very high level. Now let's try to do an in-depth analysis of how and where the bug exists. So towards my right, you actually see the Android POC application, which is a vanilla WebView implementation. As you can see, we have a button over there. As soon as you click on a button, it simply triggers a call to the backend, to our backend, which we have written. I'll talk about it in the next slide. So previously we spoken about authenticated load, right? So this is an example of an authenticated load. If you can see, we are using load URL as well as we are setting the header as authorization, and basically whenever this URL is loaded, the authorization header along with the value in an actual scenario, this will contain a JWT token of the user, and this will be sent to the loaded URL. So this was the this is a small code snippet, and if anyone wants to understand this issue, you can we have given a GitHub reference over here. You can go and have a check on the code. So in this slide, what you're able to see is a Python Flask code. Here the function hello world is simply doing a redirect 302 redirect scratchpad.org. So here we have just taken an example of scratchpad.org, which will act as a third party over here. So if you have seen the example, what we are trying to replicate is an actual workflow in which there is a bug. So as soon as you click on the button, the Android POC button, right, it will actually request our backend server over here, and then what our backend server will do is that it will send 302 redirect response, and it will redirect to scratchpatch.org. So after it redirects the client to the third party, we try to intercept the request in in Burp Suite. You can see the authorization token, which is supposed to be the user session token, is actually exposed over here to scratchpatch.org, which is an example in our case of a third party service. So this was the actual observation. So I've captured a video where we are actually trying to replicate the bug. So let's have a look at the demo. So what you see is here, is that towards right, I have my on Android Studio emulator, and towards the left, what I'm doing is actually intercepting the request as well as the response. Okay, so let me play this video. As soon as I click, this is a legitimate request which is directed towards my identity service. So here, identity service here is my backend Python code which is hosted locally. Here, if you see, I'm doing a get, and on the authorization, on the authorization header, I'm sending a secret header over here. So as soon as I forwarded that request to my backend, as expected, my Python code is redirecting with 302, and it is redirecting to scratchpatch.org. So now let's see what happens on the redirection. So after the client receives this 302 redirection, the expected behavior is that to drop this header, right? So if you observe over here, the host is scratchpatch.org, and we are actually forwarding the authorization header, which is the actual user session token to the third party. So this was the exact behavior that we documented, and that as a bug report, and we submitted this behavior to Google. So now we have done so now we have understood the actual bug and how it happens and where it happens, right? Let's try to understand what was the rollout plan on official fix. So while having a conversation with Google, we had a couple of conversations focusing on the official fix, and finally it was decided that they will remove any extra header from the request if the request is redirected to a different origin. So they would actually observe the request, and if the redirected origin is actually different from the request origin, then they would drop that header, because that header could be sensitive. And apart from that, they wanted to record a metrics where they wanted to know what would happen to that sensitive header after the redirection. And the third point, which is a very important point, that they wrote a test case where they would check whether this fix is actually working or not, whether the extra header are actually cleared or not. If the app loads, if app loads the same redirected URL into load URL. So if you guys are interested, then you can actually go at this specific URL and look at the diff as well as the test case that we are talking about here. That's all from my side. Now I will hand it over to Shiv, and he will talk about commonly WebView issues.
Thank you, Imdad, for the detailed analysis on the Chromium CVE. Now let's understand the common WebView-related security issues that we have observed over time. So these are the 4 most common WebView-related security issues that we have observed over time. The first one is lack of URL validation. Whereas the second one is insufficient URL validation. So basically, both of these issues are pertaining to loading a URL in a web view and having insufficient validation or no validation at all. The third one is unintended leakage of sensitive data to third parties. So basically, this category of issue is very similar to one we discussed while describing the CVE, wherein unintentionally we are sharing users' information to third party. Last but not the least is insufficient web view isolation, wherein we use our own web views to load untrusted content. So this was just a brief about these issues. We'll talk about them in depth in the upcoming slides. So let's understand, as I mentioned, the first and second issues are somewhat because of the amalgamation of deep links, intents, and web views. So let's understand this with help of a use case. So let's say we have two different screens. I'm referring to them as screen just for the simplicity. It would be an activity in the case of Android and view controller in the case of iOS. So just for the simplicity, let's call them screens. So we have two screens, and one screen is having a button. Once that button is clicked, it actually calls the second screen, and second screen is having a web view component. So while we are calling the second screen, we are also passing a URL. Maybe it could be as a part of intent or a deep link. And the URL that we are passing would actually load in the web view component. Okay, so so basically, the first screen would have a button. Once we click on a button, it would open a second screen, which is having a web view, and the URL that we are passing while calling the second screen would be loaded in that particular web view component. So as I mentioned, there could be two ways. We could pass the URL, or we could invoke the second screen through a deep link, or we could invoke the second screen through vanilla intents. So they would be somewhat like this, wherein I have a deep link and I'm calling this particular screen type, which is web view, and the web view URL or the URL to be loaded is passed as a deep link parameter. The second one is vanilla intents, wherein I'm directly calling the component name, and the URL to be loaded is sent as a part of extras. So basically, just to elaborate for people who are not aware of intents. So intents are kind of messages which are used in inter-process communication. So you can call one of the application components through another application components using intents. So while sending an intent to this particular component, I'm also sending the URL to be loaded as part of extras. Okay. So this was the use case. Now let's see if we have no validation at all. So what could go wrong? So if I have no validation at all, what I could do is, as an attacker, I could craft this deep link in such a way that I could replace the web view URL with some malicious URL. So application was expecting some legitimate URL based on the functionality, but I could change that web view URL to some malicious URL. And the moment I click on or trigger the deep link, the component would be invoked and the malicious URL would be loaded in this particular activity or view controller. Secondly, in the case of intents, the similar thing could happen. The application was expecting a legitimate URL, but I could craft the intent in such a way that I would change this legitimate URL with malicious URL. And the moment it's triggered, the component would invoke, the web view component would invoke the malicious URL. Let's go into the code snippet. So I have this code snippet for Android, wherein I have vulnerable code snippet for WebView demo app deep link. So basically, if you see this deep link, it actually has a URL in it. So once this deep link is triggered, the second component is invoked. We pass the URL out of it, and if you see, I'm using load URL API, the one we discussed while talking about WebViews. So I'm just passing this URL to the deep link to the load URL API without any validation, and the URL is loaded. So again, like I could change it with some malicious URL, let's say evil.com, and I trigger this deep link and it would load evil.com. So again, let's understand this with help of an example. I have a WebView demo app. The link is available. We'll share it once we are sharing this deck. So basically, this vulnerable WebView app is having an activity, and it is the activity is having a WebView component in it. So once this activity is loaded or like it's invoked, we are calling the WebView component. And here, instead of using deep links, in the case of previous example, we are using intents. So what happens is we are calling this particular activity, which is having a WebView component, to an intent, and intent is having the URL to be loaded as extras. So if you see, I have load WebView method. So the moment I have called this activity on create, I'm calling load WebView method, and load WebView method fetches the WebView object out of the UI element, and it loads the It loads that URL found through the reg URL extras in the intent directly without any validation. So as I mentioned, what we could do is, as an attacker, we could craft an intent in such a way that we could change the legitimate URL with some malicious URL. And the moment this intent is triggered, it would load that malicious URL into our app. So here we are using ADB and Activity Manager. So basically through Activity Manager, we are invoking this particular activity, which is registration WebView. So basically this activity is a UI screen, which is having a WebView component. And in the extras, if you see, I'm passing reg URL parameter, which has the evil.com. So I could change it with some malicious URL. So let's say what happens when we trigger this. The moment we trigger this particular intent through Activity Manager, it opens evil.com in our own app. Okay. So this was kind of a demo for no URL validation. Now let's see what happens. So yeah, let's see what happens when there is insufficient URL validation. So again, we have the same WebView, same deep link. And in this particular case, we have WebView demo app. It is having a URL, but now we are performing validation. So if you see, I'm parsing this particular deep link, and I'm passing this deep link and extracting the host out of it. So if you see, I'm extracting the host out of the URI object, and I'm comparing it with shivsani.com, which is kind of a whitelisted domain. So I'm expecting this to have only shivsani.com. So I am comparing it with a whitelisted domain, which is shivsani.com, or a subdomain of shivsani.com. And then if it matches, then I'm loading a URL, else I am rejecting the load. So if you see, this is following all the standard recommended approach of a validation, which is a whitelisted based approach, and then we are specifically checking for a certain domain. But still it's insufficient. Let's understand why. So basically there was an issue identified in the implementation of getHost method. So what happens is getHost method behaves differently when a crafted URL is being provided to it. So if you see over here, I have a string URL, which is actually having two domains. So these two domains are separated through backslash and @ symbol. Okay, so one is attacker.com, the other one is legitimate.com. And these two domains are separated through backslash and @ symbol. And the moment this kind of crafted URL is provided to getHost, it would actually take the second domain instead of first domain. So it would take legitimate.com and would pass the validation. But however, when the same URL is being passed to load URL after validation, it takes the first domain. So this is how you could bypass the implementation. So that is why it's not recommended to use getHost-based validation. You could read more about this in a very great report by Buggy Pro and HackerOne. So we have the link here. You can go to this link once we release the deck. So basically, whenever we are using getHost-based validation, we should not rely on getHost-based validation just because it could be bypassed if a crafted URL is being provided. So basically, this issue was actually fixed in API level 28 based on my analysis. And however, API level 27 and below in Android are still vulnerable to it. So whenever we are doing a validation, we should refrain from using getHost. And instead, we should use getAuthority and scheme-based checks. We'll talk about the ways wherein we could do URL validation securely in the upcoming slides. So if you recall, okay, in both the cases, in the first one wherein we have no URL validation at all, and in the second one wherein we have URL validation using getHost, but it could be bypassed, what could be the impact? So basically, impact somewhat remains the same because it totally depends upon the privileges of the underlying WebView. So the impact could be as severe as doing a remote code execution on the end user's device, or just displaying some HTML to phish the users. So it totally depends upon the privileges that the underlying WebView is having and what we could do from there. So let's understand a few examples. So let's say WebView is having privileges to execute JavaScript. In that case, we could just run malicious JavaScript. In the scenario wherein WebView is privileged enough to have some JavaScript bridges attached, so what JavaScript bridges would help is, or JavaScript interface would help is, we could call the native method, that is Java or Kotlin, through JavaScript. And that is how we could even call some sensitive methods and exfiltrate user's auth token as well. Or in certain scenarios, we could escalate this particular attack by accessing local storage and content providers and exfiltrating those files and send it to our command and control. So it totally depends. So in both the cases wherein we have no URL validation or insufficient URL validation, it totally depends upon the privileges of the underlying web view. The higher the privileges are, the more the impact would be. So now we are through with the first and second issue. Let's talk about the third one, which is unintended data leakage. So this would be a family of issues having all the issues related to sharing unintended information with third parties. So be it sharing users' auth tokens in referrer headers or some query string or doing authenticated loads over third parties. So let's again understand this with help of an example. So if you see over here, I am leaking users' auth tokens to Google Tag Manager. And this is something which is very common and we have observed in a lot of mobile applications. So after a auth flow, the ID token is being sent to the third party. However, we are also sharing the ID token of user to some different third party, which is Google Tag Manager over here. Or it could be doing an authenticated load to a third-party domain. So authenticated load is only meant to share our auth tokens to our identity service and not to the third-party service. So in the scenario wherein we are doing authenticated load over our own over a third-party domain, we would be leaking users' auth tokens. If you see over here, I am sending the users' auth token to thirdparty.com. The third one is again, a category of issues wherein we are sharing sensitive data over query string. So if you see over here, I'm sending users auth tokens as a part of query string. And if this is the case, or if not auth token, it could be any sensitive data. So let's say it could be users PII. So in this particular case, all this data would be logged in the backend logs. And whoever is having access to those backend logs, be it QA engineer, be it web developers, be it mobile developers, or security engineers, all of those set of engineers or users would have access to those sensitive data. So that is why it's not recommended. So whenever you need to send any kind of sensitive data, we should not rely on get and send it as a part of query string. So now we are through with the three issues. This is the last one, which is lack of web view isolation. Again, let's understand this with help of an example. Let's say we have an application which is onboarded with different third parties. Okay, and user is able to provide or access services which is provided by our application and also access services provided by third-party services. And the user is able to access the third-party services through a web view. So the moment a user sees the tile for a third party, the tile is being clicked, it opens a web view and third party renders the content on the web view. So in the case we are using our own web views to or we are allowing partners or third parties to use our own web views and load their content, it actually opens a door for exfiltration of data. So today, the data might be legitimate and expected, but tomorrow, let's say if there is a breach of trust or the partner itself is compromised. In all those cases, the legitimate data would be replaced with some malicious data. And again, it totally depends upon how privileged that web view is that we are sharing with the partner. So if that's the case, we would be again opening a door for unintended data leakage or exfiltration of data in case there is a breach of trust or a partner compromise. Again, the question comes, if this is a functional requirement of the application, how to solve it? So in that case, if we want to have a web view approach only and we want to load partners content over web view only, we should rely on Chrome custom tabs and Safari view controllers. We'll talk about them in detail in the upcoming slides. So this was the common web related security issues that we have observed over time. Now we'll talk about the learnings and recommendations as the way wherein we could prevent these issues and make our web views secure and robust, which would make our apps robust and secure. So Imdad will be taking over from here. Over to you, Imdad.
Thank you, Shiv. Thank you, Shiv, for the detailed explanation and explaining the audience about different kind of web views and different kind of common security issues and how we could exploit them. So far what we have spoken about is that our journey from the initial research and towards the towards getting a CVE, as well as we spoke about how what are the different sets of exploit that could actually happen when you are not performing an secure URL validation, how an attacker could exploit, and different set of functions. So as you know, as it says, of course we know how to exploit it, and we know what are the different ways to exploit. So it's also important how it's also important to learn how to do, you know, a secure validation, how to implement Webviews securely. So from here onwards, I will be talking about the learnings and the recommendations, the learnings that we learned throughout this entire research and throughout the entire project. So the first and foremost thing we'd like to talk about is secure URL validation. As you have seen in our previous slide, when we are talking about browsable activities, deep links, web view, it is always important to have a secure URL validation. So whenever we are loading a URL in the web view and the URL is coming from an untrusted resources, or the URL is coming from an intent or deep link, we should always have a get authority check on the specific URL and match it with a list of whitelisted domain. So why are we suggesting get authority check instead of get host? We have already seen in the past how attackers are able to bypass the get host check. So it is always recommended to have a get authority check. We should not directly load the URL. We should always have a get authority check. Along with that, we should always check the protocol. For example, the code snippet that we are seeing in this screen is an example of securing Android. So we have the function validate URL over here, and we are extracting the authority, and as well as we are extracting the scheme. So if only this both condition matches, then only proceed it to load in the web view. So that is the first set of that is the first set of principles that you must follow in Android, and this is how you can do it in Android. So let's see how it can be done in iOS. So this code snippet is a Swift code where we are using the component structure. The component structure provides the URL component structure actually provides different properties with which you can extract the host as well as the scheme from a specific URL. If you see at this code snippet, we have a check of the URL. We are actually extracting the protocol with URL components.scheme as well as the host using URL.host. So if both of this condition matches, then only it will do. Then only both of this condition matches, and if it matches with the list of the whitelisted domain, then only the specific URL will be loaded into our web. So when we talk about web view implementation, it depends upon the use case, or it depends upon the functionality that we are trying to implement. So let's say your you don't have to integrate your web view with your native application, or you don't have to share any information from your native application to the web view, or from the web view to the native application. Let's suppose you want to isolate your web view. So in that case, Chrome custom tab as well as Safari view controller comes into picture. So whenever you are trying to load a third-party content, we must always use these two things. What this will do is it will open the web content into the browser, and this browser will be embedded into our application. The web content will be loaded inside our application, but in real, it is actually running as a part of the Chrome and Safari process. So what is the advantage of using custom Chrome tab as well as Safari view control? The advantage is that in case the legitimate content of the third party is actually replaced by a malicious content, it will not any way affect our application, because it is running as a part of different process. Also, it actually provides a seamless user experience when you switch it from the when you switch from custom Chrome tab or Safari View Controller to our native app. So this is the reason you should use custom Chrome tab as well as Safari View Controller. So let's try to understand how you can harden your web views in Android. So if you look at Android web views actually have access to the content provider as well as the local storage by default. So if your functionality does not, if the feature that you're going to implement does not require this access, then you can explicitly set them, explicitly disable them using set allow content access as well as set allow file access. And you must always reduce the sensitive data exposure. What does this mean is that you should flush the cache whenever the component is no longer required. So for that purpose, clear cache comes into picture. And the last important part is whenever the JavaScript is not required, it's not used in your web view, then you can explicitly disable that function using set JavaScript enable. So now that we have seen how can you harden your web view, let's have a look how this can be achieved in iOS. So in iOS, there is a class UI web view which is actually depreciated starting from iOS 12. So that if your application is having UI web view, then the App Store will basically not accept your application, and it will not allow to update your application if you are introducing UI web view. Why? Because it comes with a lot of security sensitive setting that is enabled by default. So, and apart from that, it also comes with JavaScript as enabled, and even you cannot programmatically disable it. So that is the reason we should avoid using UI web view. So the successor of UI web view is WK web view in iOS. So WK web view comes with a lot of security improvements and with a lot of settings that are actually by default disabled. So the first one is that the JavaScript is enabled by default, but there is a property JavaScript enabled with which you can actually disable JavaScript if your functionality doesn't demand it. The second one is that hash only secure content. The hash only secure content property will make sure that the content loaded inside a web view is retrieved through an encrypted connection. And the third property is allow read access to URL. So this property is often used to load static content from your local storage. So when you are trying to use this specific function inside your app sandbox, do not give access to the local storage directory, rather specify that specific file. And last but not the least, the security sensitive settings, which actually gives access to the app sandbox and the local directories and storage, are disabled by default in WK web view. So I think as we are moving ahead, towards the end of this presentation, let's look back and see what are the learnings and what are the actual key takeaways from the entire research and from this entire journey. The first and foremost point is follow the principle of least privileges while configuring the web view. What does this mean is that you should not leave your web view overly permissive if your functionality doesn't require that specific property or that specific function. For example, disable JavaScript if you don't require it. Disable the property that we spoke about if your function, if your feature does not consume it. Secondly, use custom Chrome tab and Safari View controller if you are loading an untrusted content or if you're trying to load a third-party content. Thirdly, if if a web view is programmed to receive a URL from a specific deep link, make sure you have a strong URL validation. As we have seen in the previous slide, we gave two examples explaining how you can retrieve the protocol as well as the authority or the host from a specific URL. Have a strong URL validation against a set of whitelisted domains. Fourthly, when you're trying to validate the URL, you must always make sure that you don't use get host in Android, as we have seen how insecure it is and how attacker can actually bypass it. So always use get authority in Android and get host in iOS, and always make sure that you also check the scheme, which is the protocol. Last but not the least, this is somewhat related to the CVE that we actually reported. While you're doing a third-party integration, make sure that no sensitive information is actually shared unintentionally. This is very important. While you're actually let's suppose you have an application with Webviews and you're integrating a lot of third parties. So how would you know that what sensitive information you are sharing? Like example, the first approach you can take is what Google did. Like they had a test case before releasing that fix. So you might want to have a test case which is actually checking whether you are forwarding any sensitive content or sensitive headers to the third party. Second thing is that you can have a check on your network logs. So you can have your log parser, which could actually check for sensitive content based on the pattern, and if it looks like that you are unintentionally sharing the data, it will raise an alarm on that specific instance. So we would like to thank a couple of people, like so we would like to thank Mona Vinothan and Changmuk Ling for helping us through the entire analysis. Mona Vinothan was involved in the complete end-to-end analysis from start till the beginning, and he was a big motivator for us. And these are the references that we have used in our research as well as in preparing the presentation. We have taken a lot of references from OOPS MSTG. We have taken few of the references where we are talking about sensitive securing URL from this link, and this specific link is the disclosure where you can go and check like what have we submitted and how was the conversation with Google, and more detail about the bug. So finally, this is the live slide. So thank you for joining us, and if you have any questions in related to this specific topic, in related to this context, you can go and ask in the Discord channel, and we will be available to answer all your questions. Thank you.
Thank you, everyone.